So what we're going to go over in this video is factoring quadratic expressions. So what does it mean to be a factored expression? Well, here's an example of a factored quadratic. X plus 1 times x minus 2. This is an example of a factored quadratic. Okay? Your expression is considered factored if it's written as a product. Okay? So notice, this is a factor, and this is a factor. Okay, so when you have an expression written as multiplication, that means it's written in its factored form. So x plus 1 times x minus 2, that is the factored expression. If you wanted to write the standard form of this quadratic, okay, you do the opposite of factoring, which is distributing. Okay, you want to see all of your terms of your quadratic expression. You can't see all of those terms when you're in factored form, but factored form, okay, means two things. It means it's written as a product of its factors, and think about what factors is, okay? You know this from your knowledge of numbers. A factor means that it can divide evenly into what you have, okay? So 3 is a factor of 6, so 3 divides evenly into 6. So if I want to put this in standard form, I would multiply out, that's x squared minus 2x plus x minus 2. That's x squared minus x minus 2, okay? So that's the standard form. These two expressions are the same exact value, okay? They equal each other, it's just this is the factored form, okay, written as a product, and this is the standard form, okay? So what we're going to get into is factoring quadratic expressions. You probably have some practice from Algebra 1, but we're going to stick to quadratic expressions right now because we are in the unit of quadratic functions. So we're going to go over the 3 ways you need to be, the 3 factoring patterns for quadratic expressions, okay? So the first, okay, your 3 patterns for factoring for quadratics. Number 1, it's going to be greatest common factor, also known as GCF. Okay, you can factor out the greatest common factor, which is the greatest factor shared by every term in the expression. Number 2 is going to be the AC method. So that will be used whenever you have a quadratic trinomial. Trinomial means, whoop, spelled that wrong. Trinomial means you have 3 terms, so it's of the form ax squared plus bx plus c. Okay. And third, we're going to learn about what's called the difference of squares. Okay, and that is going to be when you have an expression in which you have a is just any quantity, b is just any quantity. It is not the same as this a and this b. It has nothing to do with that, okay? So if you have 2 terms, and you can write them as a quantity squared minus a quantity squared, that's considered the difference of squares or the difference of 2 squares. Squares meaning perfect square. A number raised to the 2nd power is a perfect square. So we're going to start with the greatest common factor. So in the first expression, let's change number 2 a little bit. Okay, so number 1 is negative x squared plus 6x, and we have two terms in this expression, and what we're going to want is to factor out the greatest common factor. So greatest common factor includes the coefficient as well as the variables. So you look, this has two terms. The factored expression of negative x squared, that's the same as negative x times x. This is the same as 2 times 3 times x. You gotta look at its prime factoring, okay? What factors do both of these share? They only share a factor of x. So I can factor out a value of x, okay? If I factor out x, what is still inside the parentheses? Well, we have to write our new expression where we factored out x. So it's like we did the opposite of distributing. So the first term, if we took out a factor of x from the first term, that would leave us with negative x. If we took out a factor of x from the second term, okay, that would leave us with 6. To check whether or not you did this right, distribute, okay, think about distributing the x. You need to get back to negative x squared. Distributing the x, you need to get back to 6x, which you do. Now, I'm going to go over, it might be useful when the first term, okay, when you are in standard form of a quadratic, remember, standard form is ax squared plus bx plus c. So you have to have the quadratic term, then the standard term, then the linear term, and then the constant term. So when you're in standard form, when you're in highest order to lowest, okay, exponent, it might be beneficial to not have the first term inside be negative. So let's say instead of just factoring out the x, you could factor out the negative x. If you factor out a negative 1 times x, okay, negative 1 times x, or negative x, times what gives you x squared? X. Negative x times what gives you 6x? Now it's minus 6. These two expressions are equal. If you distribute both of them, you get negative x squared plus 6x. You get negative x squared plus 6x. Okay, you need to get in the habit of, if you need to factor out a negative 1, okay, each sign inside, each term inside changes sign. Okay, so you could give this as your answer, or you could give this as your answer. Because technically, greatest common factor could be positive or negative, so it could be negative 1. Okay, so the next one, we've got 4x squared minus 12x, 4, okay? This is 2 times 2 times x times x, 2 times 2 times 3 times x. Four x is the greatest common factor, okay? What's the biggest coefficient that divides evenly into both of these numbers? 4. Then this has 2 factors of x, 1 factor of x. I could take out 1 factor of x. So 4x, I wouldn't look to take out a negative because my first term is not negative. So I have 2 terms. 4x times what would give me 4x squared? That's going to be x. 4x times what would give me negative 12x? That's minus 3. Okay, so there's a second one. Number 3, notice number 3 isn't in standard form, so I would put it into standard form. So it's going to be negative 10x squared minus 4x plus 2. And so we look at our 3 terms and we say to ourselves, okay, is there any common, what's the greatest common factor between these 3 terms? Okay, I can only take out a factor of 2. Okay, so I could take out a factor of 2. So it's just a constant term that is the factor here. Notice, this is a variable factor, has the ability to change because it involves x. This is a variable greatest common factor. This is a constant greatest common factor. It doesn't have the ability to change. It's always going to be the value of 2. So 2 times what gives us negative 10x squared? That's 5x squared. 2 times what gives us negative 4x? That's going to be negative 2x. 2 times what gives us 2? You can't just leave this blank and say, oh, well, I took out a 2, that's it. No, because if this was my expression, okay, if I distribute, I only have 2 terms. That's a problem because my original expression has 3 terms. So I need to make sure 2 times what gives me 2? 1. Now, what you might do, since the first term is negative, you might not want to see that negative there. It's just you can, but you'll see as we start solving, it might be easier for you to work with problems and solving quadratic equations when that's positive. So let's say we decide to factor out the negative here. This would be negative 2 times, and negative 5x squared would become positive 5x squared, and negative 2x would become positive 2x, and positive 1 would become negative 1. And just check. When you distribute, you better get negative 10x squared. You do. You better get negative 4x. You do. You better get positive 2. You do. So either of these would be fine. Okay, so that's factoring out the greatest common factor. Make sure you see you are in the standard form, you see all of your terms, and you pull out the greatest common factor between all of the terms. Okay, so now we move on to the second. So that was GCF. And number 2 is the AC method. So you're going to use that when you have a quadratic trinomial. Okay, of the form ax squared plus bx plus c. Now, not all quadratics are factorable, which means you can't always factor a quadratic expression based on the rules that we're using here. Okay, there might be other ways that you can come about with a expression of a factored quadratic, but not all quadratics can be factored using these methods. Okay, so we're going to get our quadratic trinomial ax squared plus bx plus c. We're going to see how to use the AC method. Okay, so I'm going to give you an example. So factor each. So number 1, x squared plus 2x minus 24. Okay, we can see it fits the ax squared plus bx plus c, so I would use the AC method. Okay, so what we're looking to see is, can we rewrite this quadratic expression in a factored form, so as a product of its factors? So what you do is you multiply a by c. A is 1, right? It's a coefficient on the quadratic term. C is the constant term. Okay, negative 24. Then you write down what b is. B is positive 2. So what we're going to do is we're going to actually do the opposite of distributing two binomials here. Okay, so what you do is you look for two numbers that multiply together to get a product of a times c and a sum of b. So what two numbers multiply together to give you negative 24 and add together to give you 2? So since the product is negative, that means one's positive and one's negative. And since the sum is positive 2, that means the positive number is larger than the negative number. Okay, so there are two ways. You could just do guess and check with negative 24, but if you want to know every single combination that can multiply together to give you negative 24, we just write out all of the factors of 24. So 1 and 24, I do it like this so that I don't miss any. 2 and 12, and then 3 and 8, and 4 and 6, and 4 and 6, in between 4 and 6 is just 5, and 5 is not a factor of 24. So I check. 1 and negative 24, does that add together? 1 and negative 24 to give me 2? No. Negative 24 and 1, does that add together to give me 2? No. 2 and negative 12? Nope. Negative 2 and 12? Nope. 3 and negative 8 does not add together to give me 2. Negative 8 and 3 does not add together to give me 2. 4 and negative 6 adds together to give me negative 2. Negative 4 and 6 adds together to give me positive 2. So my combination of two numbers is negative 4 and 6. So if you can come up with two numbers that multiply together to give you a times c and add together to give you b, that means it will be factorable using the AC method. So now what we're going to do is we're not going to change the value of the expression. What we're going to do is we're going to break up positive 2x. Instead of having 3 terms, you're about to have 4 terms. So this is going to be x squared minus 4x plus 6x minus 24. So essentially we broke up 2x to be negative 4x plus 6x. So we're doing the opposite of when we FOILed an expression before. So at this point, okay, if we were to simplify, we would be back up at the original expression. But what we want is 4 terms. You always want a plus sign between them, okay? So, well, I shouldn't say plus sign there. I'll get to where. So the next thing you do is, once you broke it up, okay, so once you now have 4 terms, you do something called factor by grouping. You take the first 2 and you group them together. Now you always make sure you have a plus sign there, okay? Then whatever the sign is on 6x, you take it with you inside the parentheses. Now, you did not change the value of the expression at all. All you did was group together the first 2 and the last 2 terms. There's nothing that's changed the value of this expression because if you look, outside of the parentheses would just be a value of 1. If you distribute, you would just go back to this line. But now, what we do, this is called factor by grouping, okay? You take the greatest common factor out of each set of parentheses. So the greatest common factor here is x. And if you factor it out, you'd be left with x minus 4. The greatest common factor here is 6. So you factor out a 6 and you're left with x minus 4. Now, you have 2 quantities. You have x times x minus 4 plus 6 times x minus 4. They share a common factor. They share the factor of x minus 4. Just like x squared minus 4x shared a factor of x. So we're going to factor out the x minus 4, okay? So we factor out the x minus 4. That's like, if we zoom in on and thought about this, okay? You factored out an x, and you were left with x minus 4, right? So if we factor out an x minus 4 from this expression, we're going to be left with 2 terms. We factored out the x minus 4 here, so we're left with x. We factored out the x minus 4 here, so we're left with 6. So this factors to be x minus 4 times x plus 6. Notice, we got this to be a product of linear factors because a linear factor times a linear factor is going to give you a quadratic expression. So if you're a little confused with this right here, why don't we look at this? If I wrote smiley face squared, okay, or let's do this. X times smiley face plus 6 times smiley face. And I asked you to factor that expression. X times smiley face plus 6 times smiley face. You would factor out a smiley face, and then what would be left inside the parentheses? X plus 6. Now, the smiley face just got replaced with x minus 4. It's just because it has 2 terms that this looks a little harder to do. So the smiley face is now just x minus 4. Okay? So we'll practice this again. Okay, so now let's do another problem. So number 2, let's do 10x squared minus 3 plus 13x. So this is close to being in the standard form of a quadratic, okay? We see we have 3 terms, but we need to make sure that we have them in the standard form, which is largest exponent to smallest. Okay, we do. So now we can start using the AC method, and let's see if it works. So we have to find what's a times c. So 10 times negative 3, that's negative 30. And write down what b is. B is 13, okay? So we're looking for 2 numbers that multiply together to give us negative 30 and add to give us 13. Since this is negative, okay, that means one number is positive, one number is negative. Since this is b is positive, that means the larger number is positive. So we could go through and just do guess and check, or we can just quickly write down all of our possibilities. 1 and 30, 2 and 15. After 2, 3 doesn't work. I'm sorry, 3 is a factor. So 10 is a factor. 4 isn't. 5 is. 6 is. So we can't have any more factors. So we go through. 1 and negative 30 doesn't work. Negative 30 and 1 does not add to 13. 2 and negative 15 adds to negative 13. Negative 2 and 15 adds to 13. So that's the combination. okay? 15, either negative 2 and 15 is the same as saying 15 and negative 2, okay? So the order in which you write this down doesn't matter. So if you write 10x squared plus 15x minus 2x minus 3, it is okay. It is the same as if you wrote down 10x squared minus 2x plus 15x minus 3. It does not matter, okay? So now what we do is, now notice, this right here, if I was to combine this, I would just be right back in the previous step. But our goal is to now group this. Always put a plus sign there. Now, the reason you would be wrong if you did this, okay, don't do this. Don't take this negative and write it here, because if you did that, you would really have negative 2x plus 3, which is what you do not have. You have negative 2x minus 3. So you always put the plus sign, because this plus sign is just indicating that this is still all, right? Addition, I could write plus negative 2x plus negative 3 there. Okay, so make sure you put that negative there. So we're going to take out the greatest common factor of each set. 10x squared plus 15x, that's going to be 5x, and it's going to leave you with 2x plus 3. Now, if this is, since we were able to get a pairing, we know that this is factorable, okay? So from what we just saw, we know that we must be able to take something out. And this linear factor right here must be the same as this. Now, if I don't take anything but positive 1 out, if I only took out positive 1, okay, it looks as though these are not the same factor. However, you can take out a negative 1, okay? You can take out a negative 1, and you'd be left with 2x plus 3, which is what we wanted. So we have one quantity here, one quantity here. They both have the factor of 2x plus 3, so if I pull out 2x plus 3, if I pull out the GCF from these two quantities, what are the two quantities that will be left? Well, if I pull 2x plus 3 from 5x times 2x plus 3, I'm going to be left with 5x. If I pull 2x plus 3 from this quantity, I'm going to be left with minus 1. And so that is the factored form of 10x squared plus 13x minus 3. Okay, if you wanted to check to make sure you did it right, you can multiply out that expression and make sure you get the standard form back. All right, we'll do one more of these before we try a challenge problem and then move on to difference of squares. Actually, we might move on to difference of squares and then do another. Okay, so let's look at, we'll do negative number 3, negative 2x squared, actually we'll do this, not negative, let's do negative 49x squared minus 14x minus 1. Okay, so what we have to do is, okay, we have a quadratic trinomial here, and it's of the form ax squared plus bx plus c, so a times c, negative 49, times negative 1, that's 49. B is negative 14, so we need to think of two numbers that multiply together to give you 49, and add together to give you negative 14. So if they multiply together to give you a positive, and they add together to give you a negative, that means both of these numbers must be negative. So what two numbers multiply together to give you 49 and add together to give you negative 14? That's going to be negative 7 and negative 7. So this is negative 49x squared minus 7x minus 7x minus 1. And so now we group negative 49x squared minus 7x plus negative 7x minus 1. And we take out the greatest common factor of each set. So I'm going to take out from here, okay, negative 7x. That's going to leave me with 7x plus 1. If I factor out a negative 7x here, it's going to leave me with 7x plus 1. Okay? Now, if I know that this factor right here is 7x plus 1, then this factor needs to be 7x plus 1. Otherwise, this won't be factorable going forward. And we know this is factorable because we were able to get the 2 number that satisfies these 2 conditions. So what do I have to factor out so that negative 7x minus 1 becomes 7x plus 1? I have to factor out a negative 1. So I have 2 quantities. I have this quantity here, and I have this quantity here. So they factor out, okay, because they're the same, and then you'd be left with negative 7x plus negative 1. Okay? And you have 7x plus 1 times negative 7x plus negative 1, and I'm going to go over this one a little bit more when we actually, I'll save the challenging problems for the end after we do difference of squares, but we'll get back to a problem that looks like this. Okay, so that's it for AC method. Whenever you have ax squared plus bx plus c, make sure it's of the form ax squared plus bx plus c, and then you can begin using the AC method. Not all quadratic trinomials you will be able to use the AC method for. If you can't, then you just write not factorable. Okay, the third is the difference of 2 squares. So if you can write a 2-term expression as a quantity squared minus a quantity squared, it's factorable. So let's say we had a squared minus b squared, okay? It will factor to be a plus b times a minus b. That's the pattern. So our list of perfect squares, if we want to write them down so we don't forget, okay? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, and 13 squared is 169. Okay, so here's our list of perfect squares, and then the square root are these values here. So if you have an expression that's 2 terms and fits this pattern, it can be factored using the difference of 2 squares. So let's get started. Number 1, x squared minus 64. So if you are looking to see if your expression is factorable by the difference of 2 squares, difference means it's subtraction, and it has to have 2 terms. So if it has more than 2 terms, you know that's not difference of 2 squares. It has to have 2 terms. Since it's 2 terms, I see a minus sign in between, that's good. So if I can write this as something squared minus something squared, so that means both of these are perfect squares, okay? If I can write it like this, then it factors to be a plus b times a minus b. So what squared is x squared? X. What squared is 64? 8. So am I able to write it as a quantity squared minus a quantity squared? Yes. So that means this factors to be a is x and b is 8. So x plus 8 times x minus 8. So notice the difference of 2 squares here. This is actually a quadratic trinomial ax squared plus bx plus c, where b is 0. Okay? And that's happening because they're opposites. These numbers are opposites and everything else is the same. Okay, so x plus 8 times x minus 8. Number 2, 9x squared minus 100. So I see it's 2 terms. I see there's a minus sign. So what I should be thinking of is, can I factor this using the difference of 2 squares factoring pattern? Well, 9x squared. What raised to the second is 9x squared? 3x. What raised to the second is 100? 10. So this does follow the factoring pattern. So this is A and this is B. So 3x plus 10 times 3x minus 10. Okay, so Let's do 2 more of these. Number 3, let's do 4/25 x squared minus 1. Okay, so we see 2 terms. All right, we see a minus sign in between, so we should look to see if this is the difference of 2 squares. So even though this is fractional, okay, nothing to worry about, because when you have a fraction, let's say x over y squared, that's the same as x squared over y squared. Okay, so what we have going on here is 4/25. Is 4 a perfect square and is 25 a perfect square? Yes. So that means 2/5 x is the same as 4/25 x squared. And what squared is 1? 1. Okay? So am I able to take this expression and write as a perfect, as the difference of 2 squares? Yes. This is A, this is B. So this factors to be 2/5 x minus 1 times 2/5 x plus 1. So notice I did A minus B instead of A times A plus B. The order doesn't matter when you multiply, okay? 2 times 3 is the same as 3 times 2. So the order in which you write your factors does not matter, okay? So here's our answer for number 3. Okay, here's the factored form of this expression. Notice linear times a linear gave us a quadratic. And the last one we will do, let's do 169 minus, we'll do 36x to the 4th power. Okay, so we see that it's a minus. Okay, so let's see if this fits the difference of 2 squares factoring pattern. 169, can you take that and write that as something squared? Yes, we can. That's going to be 13 squared. Can you take 36x to the 4th and write it as something squared? Yes, that's 6x squared squared. Okay, so this fits the factoring pattern, so this is going to be a plus b times a minus b, or a minus b times a plus b. So this is going to be 13 plus 6x squared times 13 minus 6x squared. Now I know we were factoring quadratic expressions, and this number 3 is technically, this is not a quadratic expression to begin with. This is actually what's called a 4th degree polynomial. A quadratic is called a 2nd degree. We have x all the way to the 4th power. But the reason I did this is because I want you to see that the difference of 2 squares doesn't have to just be x squared. It could be anything that can be raised to the 2nd, okay? Or it can be written as anything raised to the 2nd power. Okay, so that's the difference of 2 squares. So now what we're going to do to finish off factoring quadratic expressions, in this video, I'm going to write factor completely. So that means, if I say you need to factor each expression completely, that means your greatest common factor needs to be factored out, as well as all factoring patterns have been completely factored. So you need to be left with what's called prime factors. A prime factor, okay? The only factor left in a prime factor is positive 1, okay? So let's do negative 2x squared plus 4x plus 48, okay? So my first piece that I look for when I factor completely is, does this have a greatest common factor, okay? And yes, this does have a greatest common factor. I can take out either 2 or negative 2. Now, I'm going to show you something. If I take out 2, then I have negative x squared plus 2x plus 24. If you don't like working with a negative as your leading term here, you can just take out the negative from the beginning in the greatest common factor. So that would be negative 2 times x squared
2x minus 24, okay? So now what we're going to do to finish off factoring quadratic expressions, in this video, I'm going to write factor completely. So that means, if I say you need to factor each expression completely, that means your greatest common factor needs to be factored out, as well as all factoring patterns have been completely factored. So you need to be left with what's called prime factors. A prime factor, let's
So now you don't say, oh, I'm done, I had a greatest common factor. Now you check the expression that's left. Okay, x squared minus 2x minus 24. You need to check and see if that's factorable any further. So you look and you see what you have. I have a quadratic trinomial here, so that means I have to check the AC method to see whether or not this is factorable any further. So that's going to be 1 times negative 24, that's negative 24, and b is negative 2. Can you think of two numbers that multiply together to give you negative 24 and add together to give you negative 2? Yes, negative 6 and 4. If you can't think of it off the top of your head, you have to make that list of factors that I showed you before. So that means, let's forget about this negative 2 for a second, and let's just work on factoring this quadratic trinomial down to linear factors. So it's going to be x squared minus 6x plus 4x minus 24. So we do factor by grouping. Okay, and we're just going to put this negative 2 back on at the end. Take out the greatest common factor x, so that's going to be times x minus 6. Greatest common factor here is 4, that's x minus 6. Okay, factor out, what do these two quantities have in common? X minus 6, what would be left? X plus 4. So this quadratic trinomial factors to be x minus 6 times x plus 4, and this original expression had the negative 2. So, if I multiply everything out, I'll get back to my original expression here. Some things to notice. Negative 2, constant factor. This is a linear factor. This is a linear factor. Notice it's written as multiplication, okay? So, let's do another one where we have to factor the expression completely. X to the 4th minus 1. Okay, this isn't a quadratic expression, but this is a factoring pattern we just went over, and I want to show you what's possible when you have to factor expressions completely. Okay, so looking at this one, we know that this is not a GCF because there's no other factor other than 1. Okay, this isn't a quadratic trinomial, it doesn't fit ax squared plus bx plus c. But we can check to see if this is the difference of two squares because we have two terms here, and there's a minus. So, what squared is the same as x to the 4th? X squared. What squared is 1? 1. So does x to the 4th minus 1 fit the pattern of difference of two squares? Yes. That means we can factor it accordingly. This is a plus b times a minus b. So this is x squared plus 1 times x squared minus 1. Okay? Now that I said factor completely, after you've taken the standard form and factored it, you need to check, can I factor x squared plus 1 any further? Well, it's not a quadratic trinomial, okay? There's no greatest common factor other than 1, and this can't be the difference of two squares because there's a plus sign between them. So this factor is called prime. You can't factor it any further. This factor doesn't fit greatest common factor because there's no other factor other than 1. This isn't a AC method because it's not ax squared plus bx plus c. But this could potentially be difference of squares if I can write this as something squared minus something squared. This can't be written as something squared minus something squared with real numbers because there's a plus sign there. Okay? So what squared is x squared? X. What squared is 1? 1. So this is prime, but this is not. So we have to keep going. A, B. So this expression, this factor can actually be factored further. Okay? If I do a plus b times a minus b, this is going to be x plus 1 times x minus 1. So this factors to be x squared plus 1 times x plus 1 times x minus 1. And then just check. I can't factor that any further, and I can't factor that any further. Okay, now notice this. This was x to the 4th, right? If I expand this, this is x squared, this is x, this is x. I'd get that x to the 4th, okay? So when you are factoring expressions, the first thing you check for is the greatest common factor. Then you look at basically by the number of terms. If you have a quadratic trinomial, you attempt the AC method. If you have two terms, you look for the difference of two squares. and you must completely factor each expression. You keep factoring, okay, until all factors are prime.